last lesson is an overview of linear equations in one variable. You can have an expression or you can have an equation. The main difference is that an equation will have an equal sign, an expression won't. So an expression is a sequence of numbers, variables, operations, symbols, and grouping symbols, such as the following. And an equation is two expressions connected by an equal sign. An expression can be simplified or evaluated. Those are key terms. And an equation can be solved. To solve an equation, you're looking for a solution, which is a value for the variable that can be replaced instead of the variable to make the equation true. Solution set is the set of all the possible numbers that can go into X and make the equation true. So a linear equation in one variable is an equation. It's linear, therefore it only has a variable in the first power, and it has one variable, not two different variables. So a linear equation in one variable can be always rewritten into this form. Examples of linear equations are the following. They have equal signs, they have one variable each, just x, no y's, and no other powers on the variable. Nonlinear examples, however, would have x or your other, whatever your variable is called, in various powers. So a root is a type of power, and a square is a power, and actually when you put a variable in the denominator, it's actually a negative power. So these are nonlinear examples. But let's focus on linear examples. So for linear examples, you have some possible solutions. So let's look at those three examples that we looked at before. Consider, what is the solution set of this equation? So what possible x could you put in to make this work? So if you're thinking about this, you're thinking, oh, 2 times something, take away 7 will be 3. So you know that 10 minus 7 is 3. So there's one answer there. If we stuck a 5 in for x, it would work. 5 is our solution. X equals 5 is our one solution. The other example we had was 1 equals 1. There's no variable here, but what is the solution set? What possible things make this equation true? Well, because x isn't here and you're left with one side always equaling the other, well, you have all possible solutions. All real numbers could be used. And take a look at this example. What possible x values can you find? Take a number, multiply by 5, take away 1. Take a number, multiply by 5, add 4. Is it ever going to be the same number? No. So this one has no solution. So you can see that you have three possibilities. You either have one solution, and that's called a conditional equation. You would just answer the one solution. You can have infinitely many solutions, and you would answer either identity or all real numbers. Or you could have no solutions, which you could answer contradiction or no solution. To solve linear equations, we need to produce equivalent equations, and equivalent equations are ones that have the same solution sets, by doing the following. You can either add the same value to both sides, and that includes subtracting, because adding a negative will be subtracting, or multiply both sides by the same non-zero value. This also includes dividing, because dividing is the opposite of multiplying. So let's look at a couple examples just to get you started. Here's one. So we want to work with both sides separately for a little bit until we can simplify it to the point where we can create simpler equations. So let's first reorder this using the distributive property inside the bracket here. So this will be 4, 2x. Now this is a negative 1 multiplied by this whole bracket, so you'll have negative 1 times 3 is negative 3. Negative 1 times negative x will be positive x plus 5. Distribute the other one, that's still a negative 1, remember? So that's negative 1 times 2 is negative 2. Negative 1 times positive 7x will be negative 7x. All right, we could either collect like terms or we could distribute first. Doesn't really matter, let's distribute it first. So we've got 8x minus 12 plus 4x plus 20 equals negative 2 minus 7x. So we've got 8x plus 4x gives us 12x. And then 20 and negative 12 can be also combined. We're combining like terms just to make things simpler on this side. And that will be 8, positive 8. So now we've cleaned up both sides, and now we can start adding and subtracting our terms so that we get all our x's on one side and all our numbers on the other. So we can add this 7x to both sides, resulting in 19x plus 8 equals negative 2, and negative 7x plus 7x goes away and becomes 0, so we don't need to write it. We want to isolate x because we want to know what it is, so we can subtract 8 from both sides. That'll leave us with 19x equals negative 10. So now we can divide both sides by 19 because that's a multiplication and division counteracts it. And we've got x equals negative 10/19. It doesn't seem like we can simplify this fraction any further, so we're done. You can always check your work by plugging the number in and checking if it works. Here's another example. This one has some fractions to deal with. So the suggestion here is to keep things on top together. I always like to put these safety brackets on so I know they're sticking together. And a nice way of dealing with this is to multiply the entire equation by the lowest common denominator. So the lowest common denominator for 5 and 2 is 10. So we can multiply everything by 10. And when we do that, we don't actually have to multiply this all in. We can just say, well, 10 divided by 5 simplifies to be 1 and 2. 10 and 2 become 1 and 5. And similarly, we have that here. So we're actually left with 2 times 2x plus 5. And this is why the brackets are very important, because you need to keep that together. 5 times 3x plus 1. Those brackets are actually implied by the division bars. And then 5 times negative x plus 7. All right, so now we can proceed as before. We can multiply the distribution, use the distribution property to multiply these out, giving us 4x plus 10, it's 15x plus 5, and negative 5x plus 35. Now we can combine like terms, so we've got 4x plus 10 on this side, that's done. Here we've got 15x minus 5x, giving us 10x, and then we've got positive 5 and positive 35, giving us positive 40. Now we can get the x's to the same side. Let's subtract the 10x. You could subtract the 4x as well. You should result in the exact same thing. 4 minus 10 gives us negative 6x plus 10 equals 40. Subtract the 10. We've got negative 6x equals 30. Now, because we've done it so that the coefficient is a negative there, remember, don't forget the negative. Divide by negative 6. You've got x equals negative 5. You can try that out and put it in. Last example here, I'm just going to overview the procedure that I'm sort of following in my mind as I go through this. There are several ways of solving these equations as long as you're doing the exact same thing to both sides and following all the simplification rules. But there is always a shortest way, and the shortest way is usually achieved through lots of practice and following some guidelines. So here's some guidelines. When you have fractions, you want to clear them using the LCD. In this case, you've got 8 and 6. 6 and 8 have a lowest common multiple of 24. So we can multiply all terms by 24, but remember, you're not doing just these two terms. You can't miss that other term as well. If you do, then it's not an equivalent equation. So here, we're actually taking this whole term, multiplying by 24, this whole term, multiplying by 24, and this whole term. We've got 3 terms. So before we multiply anything with the distribution property, we want to simplify. So 24 over 8 is 3. So really, we can just say 3 times 2x minus 1 plus, and then we've got 3 times 24, which is 72. And then we can simplify the 24 with a 6, which is 4. 4 times 5 is 20, multiplying into 5 minus 3x. Now we have a simpler equation that we can open the brackets using distribution. So we've got 6x minus 3 plus 72, and then 100 minus 60x. And then we can combine like terms on each side. So here we've got these two terms to bring together. 72 minus 3 is 69. Now we can collect our variable terms to one side and the free numbers to the other side. So we could add 60x, and this is actually where the algebra actually starts. The rest is just simplifying. Plus 60x, so we've got 66x plus 69 equals 100. And then we're going to have to do subtraction of 69 from 100, which is 31. So we've got 66x is 31. And when we divide, we've got x equals 31 over 66. Now, that's not a very nice number, but it's in simplified form, fraction form, and there you have it.